Have you ever wondered what happened when you type a prompt into ChatGPT? How does it understand your question? Or does it really understand? Why does everyone keep talking about tokens? Why are GPUs suddenly the most valuable chips in the world? And what exactly is an AI cluster? In the next few minutes, we'll start with the smallest building blocks of AI all the way to the massive infrastructure that powers the modern large language models. By the end, you'll understand how everything is connected together. Before we talk about LLMs, we first need to understand one important concept: tokens. What exactly is a token? One way to think about it is through an analogy. In traditional computers, the fundamental unit is called the bit. Everything is stored in your computer, your files, your photos, your videos, your applications, ultimately represented using a bit, which are zeros and ones. Now, LLMs have its own fundamental unit, which is called a token. A token is a basic piece of language that LLM can process and work with. Let's take, for example, this sentence: Hello, how are you today? This will be broken down into 7 tokens. Hello, the comma, the space how, space character R, and so on. Just as computer works with bits behind the scene, LLMs work with tokens behind. For our mental model, we can use tokens are the bits of language for LLMs. All right, now that we understand tokens, we will move on to how LLMs works. Most popular LLMs today, including the ChatGPT, the Claude, the Gemini, are based on the architecture called transformer. And what the transformer does is it predicts the next token based on the context. So I'm highlighting here the predicts because there is no understanding. It's all predictions. Moving on, the process starts with your input text. Your input text will then be converted into tokens, and your tokens will then be converted into embeddings. Embeddings are numerical representations that captures the meaning and the relationships between words and a concept. These embeddings will then flow into the transformer, and the transformer is the core model that analyzes the context of the token, the grammar, the meaning, the relationships, and patterns learned during the training. The scores will then pass to the next prediction layer, which is the layer that determines which is actually the most likely to come next based on everything that came in before. Once the token is selected, it will get appended to the growing response. Then the entire process will repeat again and again, token per token. This means that LLM is not writing the whole paragraph. Instead, it's continuously predicting the next token based on the context. Now that we have the high-level understanding of how LLM works, I'm going to showcase to you some known limitation. And from here, I hope you get a better understanding of how token prediction works. So for this example, I have here the Claude desktop with a Haiku 4.5 model. So I'm going to ask it about the time. First, don't mention any other country. Okay, so as what you can see, I don't have access to the tool, provides real-time current time information. However, I can tell you that Singapore is UTC plus 8, and it was not able to get the exact time. So here, simply, we can conclude that it don't have the same understanding as us. It's just that it's mimicking our understanding based on token predictions, but there is no way for the model to get that information unless you instructed it to call a tool. So let's say you have access to your system. Uh, use your tool to know the exact time. Don't reveal your time zone or mention any other country than Singapore. Okay, so let's see. Okay, you can see here that it's actually converting time and it actually run a bash command, which is the date, and it was able to capture that exact time. And you can see that the exact time in Singapore right now is 2nd of June 2026, 5:41. That's 12:05 a.m. And here, this is a good example to show to you that the result you get from the LLM is as good as what you fed into it. Okay. Now, another thing that I wanted to emphasize is this one. So let's say generate me a story with 3 paragraphs. And then, okay, so let's just get this one. Okay, so I'll capture these things and then go to tokenizer. So from tokenizer, I'll paste the generated uh, story. Okay, so here you can see how this is GPT, by the way, so this is OpenAI. You can see how OpenAI will consider or break down the paragraph into tokens. So this is 390 tokens, and tokens can be comprised of words or just characters. So you can see here, this is apostrophe S. So we have a comma, we have a dot, that is a one token equivalent. So yeah, you get the idea. And the thing that I would like to highlight here is the 390 tokens here is the number of times the whole process that I've shown to you earlier happened. So it happened 390 times roughly. Because as what I mentioned earlier, we produce the result token by token. And surprisingly, this simple process is repeated billions of times during training and millions of times during inference, which made LLMs able to answer questions, summarize and explain, write code, and generate ideas. Now, let's talk about the hardware that makes all of this possible. We have CPU, which is optimized for complex sequential tasks. And we have the GPU, which is best for repetitive and parallel tasks. For CPU, if you have sequence of steps where each step depends on the previous one, a CPU is excellent at handling that workload. But for GPU, instead of having few powerful workers, imagine having thousands of workers performing similar operations simultaneously. And that's exactly what AI workloads need. Training and running LLMs requires enormous matrix calculations that can be split across thousands of parallel processors. This makes GPU dramatically faster than CPUs for AI workloads. CPU remain essential for coordinating system and handling general purpose computing, but when it comes to training and serving LLMs, GPUs do most of the heavy lifting. Now, let's zoom out even further to know where these GPUs actually live. Traditionally, companies operated on a general purpose infrastructure. And a typical data center commonly is a mix of web servers, application servers, database servers, storage, and network equipment. And these are designed to support many different applications and workloads. An AI cluster, on the other hand, may contain thousands or even tens of thousands of GPUs that are connected and working together as a single compute system. And this system is purposely built, of course, to train and serve LLMs to millions of users around the world. So next time you prompt ChatGPT or another model, you know that your request is being processed to one of these AI cluster. And that's it for this presentation. As a summary, we discussed about tokens, which is the fundamental unit the LLM can see. And we also discussed about the transformer, which is the engine that actually processes those tokens. And we discussed about the GPUs, the hardware behind the calculation, and the AI cluster and infrastructure behind all of these calculations. And that's about it. Thank you for watching and see you in the next video.